Hey friends, welcome to Swadev, where learning tech is simple, exciting, and fun. Today we are diving into the fascinating world of computer programs, the heart and soul of how our devices come alive. So grab your curiosity and let's get started. So our today topic is Introduction to Computer Programs. Here we learn about what are the fundamental concepts in software development interfaces and their methodologies. So let's start our today lesson. When we interact with computers, there we can know about software development approaches. There are two types of software development approaches. First one is graphical user interface and second one is command line interface. There are some differences between of them. In the graphical user interface, it is user-friendly interaction with visual elements. For examples, buttons, icons, like that. But in the command line interface, that is in text-based interface, there's no any graphical elements. So in the graphical user interface, it is easy to learn and use for beginner also. By clicking a button, execute programs, just like that. But in the command line interface, users must type commands to interact with the computer. Also in the graphical user interface, elements like graphical icons and audio indicators enhance usability. In the command line interface, it is very hard to understand and remember the commands because if user want to open file, delete file or edit file like task have to do, then have to remember commands. But in the graphical user interface, there are no need to remember commands but use just one mouse click. After learning about software development approaches, now we can learn about programming paradigms. There are two types of programming paradigms. First one is visual programming, another one is traditional programming. Like GUI and CLI, there are some differences like that. Visual programming and traditional programming also has some differences. So in the visual programming, that describe processes using illustrations and using less coding required. But in the traditional programming, there are used manual process where programmers write entire code. So in the visual programming, it is very user-friendly and easy to learn and use. But in the traditional programming, requires deep understanding of programming languages and their syntaxes. So in the visual programming, symbols are recognized faster than text. Built-in objects simplify development like that. And the traditional programming focuses on detailed sequential instructions. So here we can say about visual programming is like building a program using drag and drop like and connect colorful blocks to create a program. But in the traditional programming is like writing a recipe in detail step by step in code. Both paths lead to working programs, but one more visual and the other one is precise writing. So now, what is a computer program? Do you know about that? Okay, let's meet it. Simply put, a computer program is a list of instructions written in a programming language that the computer follows to complete tasks. Like you opening your email, playing music, editing photos, like that. So in the definition, a computer program is a sequence or set of instructions that written in the computer programming language for a computer to execute a specific task. So these instructions are followed and execute one after another to perform a specific task or few tasks. Also, without programs, even the most powerful computer is just an empty box. So, computer program is very useful and very important to a computer. So, what is computer software? Okay, let me give an example for you this. Just think a book rack. In the book rack, there are so many books. So, let's get a one book is a program. It is just a program. So the computer software is like a book of rack that have so many books, like so many programs are like a collection. So, while a program is one specific set of instructions, a software is a collection of many programs working together. I will give another example. Think of it like a restaurant. Each program is a chef cooking one dish, but the software is the entire kitchen running smoothly. So, while computer programs are individual components, software encompasses multiple tasks requiring numerous programs to function comprehensively. Programming languages means just like humans speak English, Spanish, Sinhala, Tamil, like that, computers understand programming languages. A programming language is a specialized language used to write computer programs enabling a computer to perform computations. So there are thousands of different computer programming languages have been created in year by year, more emerging annually like that. So for examples for programming languages, C++, C Sharp, Visual Basic, Java, Python, there are so many thousand exist and each built for different purposes. So now we learn about what is the programming language. So there are forms of programming languages. There are two types, imperative form and declarative form. In the imperative form, there you can tell the computer every single step, like explaining how to make a tea in step by step. So in declarative form, we can just say what you want, make tea, and the system figures out the steps for you. So in the definitions, a sequence of operations to perform is explicitly specified is imperative form. In imperative form, all instructions must be written sequentially, detailing how to achieve a result. But in the declarative form, it specifies the desired result, not how to achieve it. You simply state the requirement and the system adjusts the code accordingly. Now we can learn about what is source code. Source code. Do you hear about this? Source code means human readable instructions or human readable form. Just think that is the code you are typing in your text editor or IDE. So source code is the human readable version of a program. We write it in a programming language and then it's translated into machine code that the computer can understand. So it needs language translators like compiler or interpreter to be executed, as computers can only directly execute their native machine instructions. So in the previously we told about that we need language translator for our source code to make into machine code. So what is language translator? Language translators allow programmers to write instructions in specific programming languages and convert those instructions into the machine code or machine instructions. Then the computer can read and execute these machine code instructions and perform that relevant task. So also there are two types of language translators in primary. First one is compiler and other one is interpreter. Compiler is translate the entire source code at once, but the interpreter translate the source code line by line. So how a compiler works? A compiler takes your full program, scans it, finds errors, and turns it into a machine code. So just ready to run fast and securely. So in the definition, a compiler is a language processor that reads the complete source program written in a high-level language as a whole and translates it into an equivalent programming in machine language in one go. So in the compiler, when it works, batch processing is happened. That means translates the entire program at once. Also, the error reporting in happen there. That means list all errors after scanning the whole program. Then generate object code. Object code means machine language code. Also language dependent. Each programming language has its own specific compiler. That means Java compiler is developed for the Java language and C# compiler is developed for the C# programming language. Let's move to how an interpreter works. In an interpreter works line by line, translating and running each command immediately. It is great for testing and fixing errors quickly. So in the definition, an interpreter translates a single statement of the source program into machine code and executes it immediately before moving to the next line. So in interpreter, when it works, line by line execution happens. That means translate and execute one statement at a time. Also, the immediate error detection is happen there. That means it stops execution and displays an error message upon encountering an error. But like compiler, here does not generate intermediate object code. Interpreter works in Perl, Python, MATLAB, JavaScript, Ruby like programming languages. There are key differences between compiler and interpreter. In translation, compiler converts entire source code at once. In the interpreter, it converts and runs line by line. Analysis time. Compiler takes more time to analyze source code, but interpreter takes less time to analyze source code. Execution time. Compiler overall execution time is faster, but the interpreter overall execution time is comparatively slower. In the error reporting, compiler generates error messages after scanning the whole program, but the interpreter debugging is easier as it stops at the first error. Memory usage in compiler requires more memory for object code, but in the interpreter it is require less memory because there is no object code. In the security, compiler has more useful for security purposes, but in the interpreter it is slightly more vulnerable in terms of security. So compilers are like baking a cake. You prepare everything, bake it, and only then test it. But in the interpreters are like cooking soap. You taste and just along the way. So in the execution 4, there happens the high-level language into machine code. So the journey is write, translate, and execute. This is the heartbeat of every program. So the process of program execution involves several key stages, from human-readable code to machine-understandable instructions. So the first key stage is source code. It is written in high-level languages like C++, Java, and Python. So in the second step, it translate happen. That means convert source code into machine language for execution using compiler or interpreter. So in the third step, machine code. The binary instructions directly understood by the computer. After that, the last stage is CPU execution. The computer reads and performs the machine code instructions to perform tasks. Beyond the compilers and interpreters, we can learn about assembler. So, what is assembler? It is used for translating assembly language into machine code. It generates object code that can understand by the computer. Also, assembly language is similar to machine code but more human readable. Also, we can learn about debuggers, which help find and fix mistakes in our programs. Debuggers help identify and list errors in our programs that we can't find initially. Here we come for our end of the lesson. So our key takeaways in this lesson is interface choice. Under this, we learn about what is GUI and what is CLI. And then we learn about what are the computer program and computer software and language processors. And it is how essential for converting human readable code to machine code. So then we learn about what is the execution flow of human readable form code to machine code. So there we learn about compilers translate fully and interpreters execute line by line. So in the last, beyond the compilers and interpreters, we learn about debuggers and assemblers. Also remember, these are the building blocks of the programming knowledge. And that's your quick but powerful tour of computer programs. If you found this helpful, let's keep learning together. So hit that subscribe button to like your compiling your first program, because the best code is the one we write together. Also put your comments and questions under the comment section. So see you in the next video.